For this example, research was conducted into the 4,927 fatal police shootings in the United States since 2015, where I'll say that this data goes up to, I think, July of last year. Categorizing them by race, where the pie chart given shows the results, and we want to find the probability that the next incident will involve a person who is white. Here, we need to think about this in the same way that we did with that last example, even though we really should bear in mind that these numbers maybe have a bit more weight to them than others, as we're not talking about social networking site users or dice rolls. We are talking about people's lives in this case. But regardless of that, if we want to find the probability that the next incident will involve someone who is white, based on this empirical data, we're going to take the frequency of white people in the data set and divide by the total frequency, 4927, to get a probability of about 0.507, or about 50.7%, which says that based on our information, the most likely outcome of the next fatal police shooting is that it will involve a white person, based purely on the number of occurrences in the last 5 years, technically. The last 5 years up to last summer. But it's important to understand here that when we're drawing this data, it may not tell the whole story as it is. When it comes to getting raw numbers, there are other things that can influence it, and there are other greater contexts that may be worth discussing here. That, for example, looking at these just as raw values tells one story, but if you adjust the data to instead represent it as the number of shootings with race represented per million, that is, you talk about it in the context of how demographics shake out by race, we get a very different data set.